If I were to ask, what is the most basic building block that things are made of? How would you respond? Most people would say the answer is atoms. I can't blame them, since that is the answer that has been drilled into our heads for years through school and other means. While there is no doubt that atoms do make up matter, there are definitely smaller building blocks. In an atom, there are three types of subatomic particles: the proton and the neutron in the nucleus, and the electron orbiting it. These represent the limit of depth schools usually delve into while looking at particle physics. Let's dig deeper. This chart, called the Standard Model of Particle Physics, is to particle physics what the periodic table is to chemistry. It is the most widely accepted scientific view of the building blocks of the universe. It shows the particles that are currently believed to be fundamental and which cannot be broken down any further. In it, you can see the 6 types of quarks, which make up protons, neutrons, and all other types of hadrons. Also visible are the 6 leptons, one of which is the electron. On top of those particles, there are the force carrier bosons, which translate the fundamental forces of nature into particles that interact with matter. Last but not least, there's the Higgs boson, which gives the property of mass to all of matter because it interacts with what is known as the Higgs field. That was certainly a mouthful, wasn't it? Indeed, the current understanding of matter is quite complex, and even with all of those particles, we still don't have an explanation for the majority of the universe. The Standard Model seems to break down when trying to explain certain phenomena, such as the origin of the universe through the Big Bang, the time and space distortions that occur near a black hole due to its immense gravitational force, the whole world of quantum mechanics and probability, the existence of dark matter and energy, which make up the majority of our universe, and even the fourth fundamental force, gravity. While it's clear that the Standard Model is a good explanation for some parts of the universe, it simply can't be the true and complete answer, at least not in its current form. That's why scientists have been searching for a model that explains all of matter, energy, the 4 fundamental forces, relativity, and quantum physics. What they are searching for is a unified theory. The leading unified theory today is string theory. String theory goes deeper than the Standard Model and suggests that we exist within a multiverse of universes, and that all particles can in fact be broken down into objects called, you guessed it, strings. Put simply, a string is a one-dimensional object that can be either an open or closed loop. But how does a piece of string explain all of the matter and energy, you may be wondering? There are several variations of string theory, such as the bosonic and supergravity types, but the most unified form of string theory is known as M-theory. It predicts the existence of 11 dimensions. This may sound strange as we live in a 4-dimensional world, but the extra dimensions are a mathematical necessity in order for several fundamental equations in physics to remain consistent. The strings, as they propagate through space, vibrate in varying frequencies in these 11 dimensions, and it is these different patterns of vibration that make string theory so appealing. The different vibrations make the string function as different particles. For example, one type of string vibration makes the string an electron and gives it a negative charge with the electromagnetic force. This means that strings can be all the particles on the Standard Model, as well as other particles that are not yet known. They can represent both matter and energy, as well as act as force carriers. In addition to strings, string theory contains branes. Branes are essentially points generalized to fit higher dimensions. Open strings, unlike closed strings, are not closed loops and therefore need special locations for endpoints. They use D-branes, a special type of branes, to attach to in order to vibrate and perform string behavior. String theory fills many of the holes that exist in today's conventional wisdom. It has the answers for issues that the Standard Model draws a blank on. String theory explains the existence of dark matter and energy in the universe through particles that we have not yet predicted, but which may be represented through string behavior. String theory also accounts for quantum phenomena because of world sheets, which are alternate paths a string may take in its propagation. This means that probability exists and many different versions of events are possible. That means string theory reconciles quantum mechanics with the relativistic model, supported by the Standard Model, and accounts for phenomena on a very small scale. Perhaps most importantly, string theory accounts for quantum gravity, the intersection between relativistic gravity and quantum mechanics. Unlike the Standard Model, which has no current solution for this, a string would be able to act as a graviton, a theoretical particle that is the force carrier of gravity, just as the photon, for example, is the force carrier of electromagnetism. This connection means that string theory also has an explanation for the Big Bang and black holes. This is a very significant theory, but it's beyond the scope of high school math and science. Let's take a look at how string theory fits into particle physics in a more accessible way, using the analogy of a phone. Let's say this phone is an atom. It is a whole complete item that combines the subsystems into a functional system, much like an atom is the smallest unit of matter that has all the properties of the underlying element. The phone is made up of various components like a processor and memory unit, just like an atom is made up of protons, neutrons, and electrons. These items by themselves do not function the same way the whole does. However, they work together to make the whole thing function. In a phone, transistors on the circuit board use open and closed to represent the binary ones and zeros that make the phone work. They control the workings of the phone on the most basic level, but the effect translates into visible change. These represent the strings. Like transistors, strings can do multiple different things and exist in different states because they can vibrate in different patterns. And like the transistors, what a string does affects the whole hierarchy of matter and energy and results in the different particles that exist and ultimately in the entire universe. String theory is a complex idea for sure, one that puzzles even the greatest scientific minds. But I think the phone analogy clears things up. String theory is one of the most important developments in modern physics. It has explanations for many of the things we are unsure of today. One day, we may have enough evidence to support it, and when we do, it will profoundly change the way we look at the universe. That's string theory in a nutshell.